All right, now in this video I'm going to show you something called synthetic division, and this is a method of dividing polynomials without a lot of the clutter. So some of you might find this much more beneficial to have a look at. So we might jump straight into it and have a look at this polynomial, which is 2x cubed plus x squared minus 5x minus 3, and we're going to divide it by x minus 3, which we'll put in brackets. We know it as x equals 3. That's the solution, isn't it? All right, so synthetic division is laid out like this. It's drawn with an open rectangle here. We record the coefficients of the terms in the top row. We record the divisor, but notice that I'm only using the digits and no x's. There are no x's in here. All right, this is very important. So the first row contains the coefficients which have been grabbed from the polynomial. All right, now we know that when we did long division, this would jump straight down here, like so. We multiply this by the solution and write the answer here. Then we add down. So 1 plus 6 is 7. Multiply across there. 3 times 7 is 21. Add straight down. This becomes 16. Then we multiply across here. 3 times 16 is 48. Add down, and that becomes 45. Now, these are the coefficients. If we wanted, what we would then do to write the answer is to just imagine that we've substituted these back into the polynomial, which is 1 power less than the initial polynomial. So this one would have 2x squared, this one would be 7x, this would be 16, and this would be the remainder of 45 over x minus 3. So the result of dividing the initial polynomial of 2x cubed plus x squared minus 5x minus 3 divided by x minus 3 equals 2x squared plus 7x plus 16 plus 45 over x minus 3. So that will be the result of our division. And we can see there that because of the remainder theorem, there is a remainder here, which means x minus 3 is not one of the one of the factors of the initial polynomial. So doing this division hasn't really helped us factorize it, but it has shown us a much more straightforward process called synthetic division. We'll do one more example. We'll do an example that you've probably already done in the set. So this is the polynomial divided by x plus 1 here. All right, so we're going to set it up using synthetic division. We draw our unfilled rectangle. We'll write the coefficients of the polynomial along the top line, and the actual solution. So the difference between long division and synthetic division is that the number out the front here is the actual solution. All right, or the number that you would have substituted into the polynomial to find the remainder. Okay, so remember that it's not the number in the factor of the brackets. Okay, so we always carry down the first one, then we multiply here and write the answer there. We add down, minus 1 is minus 2. Multiply here, this gives us 2. Add down, so this is plus, these are multiplies. Add down, that gives us 5. Multiply here, this gives us minus 5. Add down, and this gives us 0. And you can see the difference between the first example and this one is that there is a remainder of 0, which means that this is a factor. So then I would just copy these coefficients into the polynomial with 1 power less minus 2x plus 5x. So this, not plus 5x, just plus 5. This is the leftovers when the polynomial is divided by the coefficient, the factor. So this would be where you're up to, and then if you could, you would factorize this bracket here into two sets of brackets. If you couldn't, you could just leave it.